The Coyote Canyon Mammoth Site began in 2008 on 27 acres donated by a Kennewick farmer with one stipulation: share it with the community. And that is just what the volunteer project directors have done.
This is rather a rare opportunity. Mammoth finds are common in eastern Washington. There's probably a mammoth being dug every 15 years or so on average over time. Most of those are dug by universities that want to get in and get the bones and get out, or museums that want to get in and get out. So to have a long-term project in the Tri-Cities area, the last time there was a major excavation of a mammoth here was in '79 when the West Richland mammoth was dug by the Burke Museum. And that was over the winter, very little local participation. This is just the opposite. So if you live in the Tri-Cities area, this is your mammoth for this 20 or 30 year stretch of time. And you need to take advantage of it and come out and join us and participate.
The three volunteer directors of the site have poured countless hours into recruiting and training the teams of community members, interns, and high school students that bring the science of the mammoth to the public.
I drive over from Seattle for a 10-day stay every month, and what makes that happen is basically this educational component that we have going on, the nature of the geology research that George is doing, the rewards that come from sorting through sediments and stuff. It's a very rewarding experience to see a site that's actually functioning at this level, as opposed to just a paleontology quarrying expedition to get the mammoth bones. The educational component of this thing is important to me. Gary and George and I, we all enjoy fulfilling that mandate that the property owner gave us, which is share this with the community. And they've given hundreds now of talks in the community and put bones and things on display at things like the Sandhill Crane Festival. We've carted bones around to classrooms. They've given talks to the Rotary, talks to the garden clubs. So we're doing what we can to fulfill that mandate from the landowner. And I think that kind of participation at community level is rare in terms of paleontology sites.
I've had my own education out there. I've been trying for the last few years to get teachers to bring students out. We've developed an intern program. In fact, we've actually had a week-long session of a field lab with CBC students this summer, and we're hoping that gets repeated. And we've done a similar thing, not quite so technical, for middle school kids. And I would love to see that go on again.
At the site, the reality of the mammoth brings science to life for those volunteering and visiting.
When we initially got here, following the start of our research here, what we saw at the site was a bone scatter of chips across the site. And using that, we laid out a grid, as an archaeologist would do, across the whole site, did some survey work on the surface, and started excavating based on where we saw a greater concentration of chips. That brought us down to the midsection, the ribs and vertebra of the mammoth. And so basically what we've been digging for the last 3.5 years is this midsection of the animal. And slowly we're beginning to move towards the tail and towards the head, or where we think the tail and head should be. Sometimes it's a surprise. You look at the bone scatter that we've uncovered so far and you think, well, there should be a hip over there and pelvis, and you dig over there and you don't find something. So it's not a straightforward mammoth fell over sideways on the hillside kind of distribution. So far we've excavated 14 ribs and 5 vertebrae and a couple of wrist or ankle bones. So there's a lot more to go, presumably. Several of the bones that we've excavated are in units where the bone goes back into the back wall, so we still have lots of sediment to uncover and presumably a lot more mammoth bones to find. So,
our working hypothesis currently is that the mammoth was washed in on an ice age flood, probably originated maybe between here and Spokane somewhere. And the Ice Age floods swept this animal to its death, and it came to rest on the shoreline of temporary Lake Lewis, and that it was partially buried. We're at the high end of the lake, and so the water column wasn't very thick. So we think just maybe 30 centimeters of sediment or so was deposited with the mammoth. And then the mammoth sat at the surface for some period of time and was scavenged and scattered a little bit, and then another Ice Age flood came through and buried it some more, and then maybe some, scavenged some more again, and then at least a third flood buried it again, and then eventually it got buried under windblown deposits and slope wash and protected where it is. So basically that's our working hypothesis. The skeleton appears to be at least partially articulated, so there was some soft tissue holding some of the bones together. Okay, so the age date that we have for the mammoth, we think precisely dates one of the Ice Age floods, and so that's pretty exciting. One of the things that we learned by looking at this is that it looks like it's a fairly complete skeleton. The bones are all pretty much nested together. A couple of them are in anatomically correct positions, suggesting that there was soft tissue that connected them. So we believe it was a carcass, okay? And so that kind of tells us that it wasn't just a bunch of bones that washed in. The other thing that we found in doing this is there's a strong connection between the mammoth bones and the flood deposits. They're in what we call slackwater flood deposits, or tushy beds, down in the Walla Walla Valley, and so there was that strong connection.
Certainly the one that George has talked about is the most likely and the most obvious one when you find an animal in the flood deposits. But one possibility for this collection of bones is that it's not one animal. It's a series of bones that have been picked up on the landscape, and because of similar densities, they're all brought to the same area by a flood and then released and deposited in that same area. But they don't necessarily represent one carcass of one individual. That's a possibility. A third possibility is that this is an animal that was above the flood when the flood came through and isolated on a hilltop, needed to get to water, and worked his way off the slope down across fairly muddy terrain and got mired down in the muddy terrain and died under those circumstances, bogged down. So that's kind of three possible hypotheses of how the bones got there. And one of the more satisfying things about what we're doing now at the site is that basically we're getting to the point where we can start to eliminate some of these things based on the work that we've done. So
the only thing I could imagine was that a flood came through, swept the animal up, and left him on the hillside as the water was receding. I don't have the scientific training that these other two guys have, so I have the liberty of going a little wild, and so I envision him probably grazing not too far from the Tri-Cities, even though, yeah, it could have been anywhere between here and Spokane. But actually his bones aren't in too bad a shape.
I might add that I said this is our current working hypothesis. There's been a number of these hypotheses that that, you know, when we first started out, we started looking at. And one of the things that was interesting when we started to uncover this, we found an accumulation of erratics right next to the mammoth. And so that kind of led us to yet another hypothesis, and that was that perhaps the mammoth died and was caught up in an iceberg and was ice rafted in, much like an erratic. So there's a number of these hypotheses, but I think, you know, our current working hypothesis, based on all the evidence that we've got together, is still that it came in on a flood, maybe either with a chunk of ice or next to a chunk of ice or in a chunk of ice.
We go down, as I said, in 10 centimeter levels. And so if you've got a meter long rib, but it's at a 45-degree angle, you're going to have to go down a number of levels to totally expose the bone. And we don't remove anything until the dirt has been totally removed down to the bottom floor.
My thoughts on this are that it would be lovely to get the humerus out, as George suggests, but it's pinned in by vertebra in the back here. And that vertebra is actually pinned in by the second humerus, which is at a lower level, but it's catching the spinous process on that vertebra down underneath. Then up over here, I was hoping we could liberate the scapula, which is largely plate-like, but it's pinned in by a rib that runs back into a wall that we're not going to dig until next year. This rib is also pinned in the scapula and it's held down by this rib. It would be possible for us to lift this rib and hope to be able to free that one, but there's no way we're going to free this up running back into the wall back there. So you can see for the moment our pickup sticks are kind of interlocked with each other until we get down a few more floors.
And this vertebra is so broken up that you can see it's really deteriorated down here. It might be as we get down a little farther, this might, we might not lose anything by taking it out too.
Right. And I'm thinking if we can do one more floor here this weekend, that some of this is going to become obvious to us as we take this down here and take that down back there. And our biggest problem is too many bones. It could be worse if we
much order to take them out in.
Yeah, but
Well, any way you look at it, we're going to be here for years.
Yeah, but
no,
this has been in the ground and
this
exposed in the winter for
this will
like
come.
3 years.
Yeah, this will come next year for sure.
Yeah, and
That's been exposed, and actually that's not in too bad a shape.
Well, that's been boot
this was boot marks.
Yeah.
We finish taking this down, and take this down one more level, and see what happens over here.
Right.
And then boot bar this maybe, and you gotta be careful not to get the boot bar stuck between here and here.
Right. Let me ask you a question. Would it be potentially possible if we dig that vertebra down there well enough to do a plaster cast and take out the whole unit, or do you want to use boot bar?
One thought we talked about is taking this out, but then this is unsupported. Okay, and at that point maybe plaster.
With plaster, you tend to hold the whole thing in
a
relative
block,
position.
as a block,
Yeah, all the relative positions.
That is another option for us if we knew where the splash process ran. The trouble is, it looks like the splash process runs into one.
Yeah.
And if that's the case, the only way to liberate the splash process is to take one down 4 floors.
Or brick.
I'm sorry I even mentioned it. I really am. It's kind of sensitive.
There's an ongoing discussion among us about the orientation of the animal and how he got there. And we've recently discovered what we think is the second humerus, or upper foreleg bone. We've had the first one exposed for some time. The ribs have always, to me, been a set of pickup sticks. Each time we uncover some new bone, like the new humerus, I think of a contortionist, how did he get there? Well, in reality, it's taken him 17,000 years to get there. And things do move around, not only from scavenging, but he's on a hillside. And the earth is not stagnant, it moves.
I can point to a couple things. Finding that accumulation of erratics, juxtaposition to the mammoth bones was a revelation. Okay, that was interesting. So that was an interesting find. And then visually, if you do your stratigraphy and you try to map the different geologic events, some of that gets wiped out and overprinted by soil development and bioturbation. We have rodents and plants and things, and so some of that kind of gets washed away. And our working hypothesis of the stratigraphy, particularly where the wind-blown loess deposits start and the Ice Age flood deposits end, when we did X-ray fluorescence analysis, it was clear that there was kind of a mixture of wind-blown deposits and Ice Age flood deposits in this old soil. And so where we called that interface, based on the geochemistry, was about 20 centimeters different from where visually I would have called it. So there's a number of those kinds of things where your lines of evidence can help you kind of piece it together, and that was unexpected.
I've been tracking, just as George has been taking care of the geology, I've been tracking the organics, plants and animals.
Yeah, that's just a fragment off a larger, but it's porous like that. That's, it's more the inside of a larger bone.
And we do have instances, for example, of animals that occur in the flood deposits but don't occur in the rest of the sediment from the site, higher up in the site. And we have examples of animals higher up in the site that don't occur in the flood deposits. And so some of those pose interesting questions about the nature of what was the environment and the paleoecology on the site without the floods and on the site when the floods came up the valley and receded away. So one of the ways I know that we're doing good science is that we're producing as many questions or more than we're answering as we go along. And it's a good indicator that you're on the right track.
After 3 years of digging and collecting data, what are the results that intrigued the directors the most?
Well, obviously the erratics catch my eye. The fact that we've identified layers of floods material. I love finding kids at the site learning about it, to be quite honest with you, to share it with the public and especially the schools. There are a lot of, I guess we could say, modern cultural concepts in that people think that woolly mammoth is always one word and that's all there is. And that's one of our sort of pet peeves. We don't have a woolly mammoth, we have a Columbian mammoth. And to let the public know that that find is in fact what is common in the West, the far West, is the reality of the situation. So I think finding things that will change popular culture's impression of what was going on 15, 20, 30,000 years ago is exciting.
To me, it's piecing all the information together, putting all the bones together on a map so that we have a visual representation. Because as we go down through, we remove the bones as they become free. And so it's very seldom that you get a picture of the whole situation. But being able to put all the bones in context with each other and with the erratics and the geology, I think to me, that's the most interesting thing, is now trying to develop a conceptual model as to what happened, how this mammoth is laying in the geologic context. So that's the most interesting. It evolves almost on a daily basis when we find a new erratic or limestone erratics. You know, some things that we have not really seen using X-ray fluorescence on these deposits.
Right now, the work that impresses me the most has been the work that George has done to differentiate these flood deposits, both the ones with the mammoth in it and the ones immediately above and immediately below the mammoth. That's very important work. Separating, as George was talking about, separating out this transition zone where we move from flood to loess deposits. This is science that couldn't be more important, more germane to what we're trying to do in terms of the paleoecology and the paleoenvironment at the site. So the more spectacular finds at the moment are on the geology side of things, but eventually we will have paleoecology data to plug into his geology, and I think it'll make this a critically important site.
Another factor making Coyote Canyon important is the carbon dates of the mammoth bones.
Well, I have to be honest and say that I was surprised our dates came back as good as they did. Generally, the quality of mammoth bone or bison bone or horse bone in the fossil bones in eastern Washington is really poor. We can look at the record of mammoth finds in eastern Washington, and I think there are 5 with radiocarbon dates on them out of in excess of 500 finds. And it's not for want of trying. I mean, there are other people who have tried to generate dates on them. So generally, geologically, the bones are buried in sediments that allow groundwater fluctuations. Those groundwater fluctuations destroy the organic carbon within the bones. It leaches it out and destroys the bonds that hold it together. So you end up basically with pasty bones on the inside that are devoid of organic carbon, and the organic carbon is what's dated, and therefore lots of people have sent samples off only to find out from the labs that they couldn't find enough organic carbon to date. This happens in other places as well. So the Seattle tusk is a good example. We sent a sample off for dating and they came back without enough organic carbon to date. Most of the bones in eastern Washington that you see in collections and things like that won't generate good radiocarbon data if you send it off to a lab. We were fortunate, and there was enough organic carbon in ours to generate good dates. So our colleagues in the scientific community are really jazzed about the dates that we have at this site, and the fact that they are, as George mentioned, specific to a given flood, and that we have some definition between our flood and the ones above and the ones below, makes those dates very important in terms of the future interpretation of floods in eastern Washington. Mammoth finds in Washington are really common. Mammoth finds in flood deposits in Washington are really common. But being able to say we have 6 or 8 floods on this site, and ours is in the 3rd one up from the bottom, and it dates to 17,005, is something that you almost never see in the literature. So even at the simplest point of view, we are generating data that doesn't occur in the literature very often, certainly not in Washington.
Next, we'll look at the data being generated and the creative approaches the 3 amigos and the citizen scientists are using at the site.